The topic of my video podcast is how antimatter can be a reliable source of energy. The title basically says everything. My goal is to build a constructive analogy of the idea of using matter-antimatter annihilation process as the answer of the world's energy crisis. I'm basically going to go over these topics while trying to keep it simple and straightforward. Antimatter is basically a mirror image of what we define as matter, so antimatter is a form of matter in which particle has the opposite set of quantum properties. So an antiparticle of electron will be positron, same mass as the electron but a positive charge instead of a negative one. Many experiments have shown that we can only produce a pair of particle and its antiparticle at the same time. To create them it takes energy, and when you bring them back together the energy is released. This is basically what we call the matter-antimatter annihilation. The amount of energy can be figured out from the famous E equals to mc squared equation. There is a nice little chart that tells us how much energy we might get from annihilation, if we succeed to make it happen. The huge difference in different energy sources and annihilation is obvious, but we have to remember that it's not naturally abundant like hydrogen or oxygen, or it is not spontaneous like uranium-235 fission. The research about antimatter has been going on for decades, but the credit for its certain emergence in the limelight probably goes to the author of Angels and Demons, Dan Brown. In that book, some group tries to take over the Vatican City by an antimatter explosion, but there's a big difference in fiction and reality. According to the book, the annihilation can create massive amounts of energy with very little quantity, which has been proved wrong. According to research data from Stanford, when a positron and an electron collide, it would yield an energy of 1.63 times 10 to the power negative 13 joule per annihilation. The world's energy budget is approximately 5.0 times 10 to the power 20 joule per year, or 1.4 times 10 to the power 18 joule per day. This is really an insignificant amount of energy comparing to what's needed. There is another misconception that we will get massive amount of energy in no time from an explosion just like the one in the book. According to CERN, the European Organization for Nuclear Research, their LHC Large Hadron Collider creates 10 million positrons per second. As we need approximately 105 kg or 100 kilotons of positrons produced daily, which would mean it would take the LHC 10 to the power 24 seconds or 10 to the power 16 years to produce that amount of energy. Even colliding more massive antimatter particles such as antiprotons, the time scale would still be huge, around 10 billion years. So now the question is, do we really gain anything from the matter-antimatter annihilation? Does it really matter? According to CERN, the process of creating antimatter is very inefficient. A major part of the energy gets lost. A lot of the stable antimatter particles go destroyed before we can catch them. Everything happens at the speed of light. We can actually compare it with a cooking food over a campfire. Most of the heat is lost and does not go into the cooking of the food. It disappears as radiation into the dark night sky. So, we should not think that some fictional annihilation process is the answer of our energy crisis. We should invest and try to improve energy sources that are reliable and efficient, like nuclear, solar power, wind energy, and water. And let's not forget, above all, we have to consume as less energy as possible and try to make the earth greener and safer.